guys, welcome back. We just did a lot of hard work writing a proof. Now let's get to the problems. So I'm actually going to do this one first, and then we'll go back and do that. Okay, so a carpet measures, here's my carpet, 7 feet long and has a diagonal of the square root of 74. What is the width of the carpet? So they want this, the width of the carpet. So here's my carpet. I know my diagonal measurement, and I know one of the measurements. What is the width? Well, hopefully you're noticing that that's a right angle, my carpet, and I can do a squared plus b squared is c squared. So here, if the width of my carpet is the short side, the medium is the 7, and c is the square root of 74, and we're going to square that. So using a calculator, the square root of 74, which is a big ugly decimal, but then when we square it, we get back to 74. So that should make sense. The square root of 74 squared is undoing what you just did. It's simply the number 74. 7 squared is 7 times 7, or 49, and w squared is what we started with. So using the Pythagorean theorem, we can solve for w. So let's subtract 49, and we get w squared is equal to 74 take away 49, or 25. So our answer is not 25 though. We must take the square root of both sides. We get w is equal to 5. Now let's double check our answer, but it's feeling like it's looking pretty good. So how could we check our answer? We could say if the short side was 5, so 5 squared, and the medium side was 7, 7 squared, what would my third side be? So 25 plus 49 is 74. Ooh, that's what we were. So 74 is c squared, and that's exactly what we got. C squared is 74. So we've checked our work. Now let's do another similar problem. It says to satisfy a regulation, the distance from the wall of the base of a ladder is 2.5. Okay, so let's draw a picture. I have a wall and a ladder leaning against it. There you go. And they said this distance from the bottom of the wall to the bottom of the ladder is 2.5. They're saying this distance here, so I'm going to call that AB. They're saying the distance AB should be greater than or equal to, so at least 1/4 of the length of the ladder. So what's the length of the ladder? I guess I'm just going to call that CB. So the regulation states that AB has to be greater than or equal to 1/4 of the length of the ladder. Okay, now let's set this up. What if the vertical distance from the top of the ladder to the ground was 9? Is everything set up properly? Well, let's try this out. Let's call that C and see what happens. So we're going to take A squared, we'll say is 2.5, B squared, 9, C squared we don't know. Let's find out. So that's 6.25 plus 81. And we get 87.25. Now that's not our answer. We have to take the square root of both sides. We take the square root of that. And we get C is equal to 9.34 approximately. Okay, so now we say, okay, now that we know the length of our ladder, we can plug it in here and decide if everything went okay. So let's see. The quarter of the ladder, CB, a quarter of the ladder, so I still have that in my calculator here. I'm just going to divide that by 4, and I get 2.34. So is that amount greater than or equal to AB? Well, right now we have AB is 2.5. So is 2.5 greater than 2.34? You're going to say yes. So as long as C, that is our ladder, is 9.43, then 1/4 of our ladder is 2.34, and we need 2.34 to stay less than 2.5, less than or equal, and yes it is. So we are good. Okay, let's check out the back. So it says Write each trig ratio as a fraction and as a decimal and round. So you can go to Google and type this in, or using these, or maybe you have a calculator that has these functions and you've never used them. So I'm just going to show you how. So what is sine? Sine is actually the trig function opposite over hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So I'll write adjacent over hypotenuse. And tangent is opposite over adjacent. Now these formulas are on the formula sheet, but we'll be practice writing them out. Okay, but you don't have to memorize them. So sine is, so the sine of angle S, so if this was my angle S, the opposite is the number 5, the side opposite angle S, and the hypotenuse is still 13. The sine of R, so if this was my angle, a different angle, opposite R is the number 12, and the hypotenuse is still 13. Now, what would they do if they asked a different function, the cosine, that's adjacent over hypotenuse? So if I go back to angle S, adjacent is 12 and hypotenuse is 13. Cosine of R. Oh, well, if I go over to R, the adjacent side is 5, but the hypotenuse is still 13. And tangent of S, so if I went to angle S and I went opposite, that'd be 5. And if I went adjacent, that'd be 12. If I went to angle R, the opposite would be 12, and the adjacent then would be 5. That's how you set up these ratios. Now it says round the number to the nearest hundredth. Okay, so I'm going to round these numbers to the nearest hundredth just using a calculator. So 5 divided by 13.38. 12 divided by 13.92. Oh, this is the same number, 0.92. Oh, this one's the same, 0.38. 5 divided by 12. 0.42. 12 divided by 5. 2.4. Now it says, write each trig ratio as a fraction. Oh, so same thing. They've just given me some different dimensions. So let's practice this again. If my angle is A, the sine of a function is opposite her hypotenuse. So the opposite is 7 and the hypotenuse is 25. The sine of B, so if I picked a different angle, opposite of B is 24 and the hypotenuse is 25. Now, what happens if they change this trig function to cosine? Cosine is adjacent over hypotenuse. So cosine of angle A is adjacent, 24 over hypotenuse is still 25. If they switch to angle B, adjacent is 7, hypotenuse 25. Now, if they asked the third function, tangent function, tangent is opposite over adjacent. So if I go to angle A and I go opposite over adjacent, I create the ratio 7 over 24. And the tangent of B, if I go to angle B, adjacent is, opposite over adjacent, right? So angle B, opposite 24 over adjacent 7. All right, let's type all these in. 7 divided by 25, 0.28. 24 over 25, 0.96. Same number, right? Same number. Oops, I messed that one up. Oh, no, it's exactly. Okay. So, that's how you set up these ratios. If this feels fast, it's not. It is fast, but we're going to use this as notes later. So the sine and cosine of complementary angles. Complementary means two angles that add up to 90. So if we had an angle A and an angle B, they're complements if they add up to 90. That's what that's saying right there. So we know that the blank of an angle is equal to the blank of its complement. Notice here, we saw that this 0.28 and this, so the sine of angle, the sine of an angle, so the sine of A was equal to the cosine of the complement. And A and B are complements, right? In the picture, A and B have to add up to 90. Notice in the picture, A and B have to add up to 90 because that is 90 and all of them add up to 180. What else do we know? Did you also notice that the sine of B, these two numbers were equal to each other? So that's kind of why we did this, is to realize that the sine of B was equal to the cosine of A, and B and A are called complements because angle B and angle A add up to 90. So how can we use that to answer a math question? Given that the sine of one angle is 57, so we draw an angle and we say this is 57. Given that the sine of that is 0.39, write the cosine of the complement. So what would be the complement? So we can take 180 minus 90, right? And we get 90. And then we subtract 57. And we get 33. So we know this angle has to be 33. What would be the same? So 57 would be this opposite side over hypotenuse. So that would be the same as the cosine of 33. Right? The cosine of 33 should give you the same thing. So we can try that in the calculator. The cosine of 33 is, oh, my calculator is on a different setting. Hold on. Use this calculator. So the cosine of 33 should give me the same answer as the sine of 57. Let me type in the sine of 57. All right, so my calculator is not set up. It says find the measure of angle X that is the complement of 57. How do I do that? 90 minus 57 is 33. So that is all they're looking for on 7. I was messing around with my calculator though, so sorry for the delay. Given that the cosine of 60 is 0.5, write what the sine of its complement is. Well, we would know the sine of the complement of 60. Well, what's the complement of 60? 90 minus 60 is 30. So the sine of 30 should also equal 0.5. Okay, so my calculator is not set on, it's set on radians. Sorry about that, and not set on degrees. So if it was set in degrees, I would be able to prove it to you on my calculator. Sorry, I can't. So all they're looking for here is the sine of 30 and that the angle is 30 here. What they're looking for, the cosine of 33 should equal the sine of 57. And how did I get 33? I subtracted it from 90. Thanks for joining us.